All right, let's get started on our state change homework. The first thing we're going to do is we are going to convert the melting point of sulfur from Celsius to Kelvins. Now, if I'm going from Celsius to Kelvins, the thing to remember is Kelvins does not have negative numbers, so therefore I'm going to add the temperature absolute zero to it. I'm going to add 273. So I'm going to find the melting point of sulfur. Here's melting point, here's sulfur. It's 112, so I'm going to say 112, and I'm going to add 273 to it, and that's going to give me 385 kelvins. Now for number 2, what I have to do is I'm going to first convert kelvins to Celsius and then check the list up here to see which of the substances. I'm going to check the boiling point list. So what I'm going to do is I'm going to say 240. Now since I'm going to Celsius, Celsius can have negatives, so I'm going to subtract 273. Whoops, that's not a very good 7. I'm going to subtract 273, and what that's going to give me is negative 33. And when I check my boiling point list, I'll see negative 33 is ammonia. So my answer is going to be, in this case, ammonia. All right, let's try. At what temperature does iron freeze? Well, in order to answer these questions, here's what you need to do. You need to look up here at this table, at this melting point, boiling point table, and you need to remember this, that think of this like a number line with cold being down here and hot being over here. So we have 3 regions. If we're colder than the melting point, it's going to be a solid. If it's warmer than the boiling point, it's going to be a gas. And if it's between the two, it's going to be a liquid. And remember, it makes the change at that temperature, not above it or below it. So at what temperature does iron freeze? Well, here's iron, and it freezes. The freezing is a change from liquid to solid, so it freezes right here. It freezes at 1535. The next question is, at what temperature does iron boil? So boiling is a change from liquid to gas, so iron is going to go from liquid to gas at this temperature right here. So we're going to put 2750. Now let's look at the next question. Is iron a solid, liquid, or gas at 1,000 degrees? So let's go to iron. 1,000 degrees, think of this as a number line. 1,000 is down here in the solid range. Is lead a solid, liquid, or gas at 1,000 degrees? So here's lead. Think of a number line. 1,000 is in here, and that's in the liquid range. So hopefully you're seeing why it's a good idea to label our table like that. Let's keep going here. Is sulfur a solid, liquid, or gas? I'm sorry, is mercury a solid, liquid, or gas, or negative 50? So let's find mercury, negative 50. Now think of a number line. Negative 50 is colder than negative 39, so the answer is going to be solid. And then the next one says, would sulfur be a solid, liquid, or gas at 500? So here's sulfur, and 500 is up here, so the answer is it would be a gas. All right, let me look up here further. Okay, so is table salt a solid, liquid, or gas at 1,000 degrees? So here is table salt. Think of a number line. 1,000 is here, so the answer is going to be liquid. That's a terrible liquid. All right, what is the hottest temperature that sulfur can be a liquid? So let's go take a look at this. So we're looking at sulfur, the hottest temperature it can be a liquid. So here's sulfur. Here, and here's the region where sulfur is a liquid. So it's a liquid from 112 to 445. Any hotter than 445 and it becomes a gas. It becomes a gas at 445. That's where it's going to make the change. Think of it like a doorway. On one side of it it's a liquid, on one side of it a gas. At this temperature it's making a change. The answer is going to be 445. The next one is, at what temperature do molecules of mercury in a gas state begin to remain in contact? Now that's called condensation. So we're talking about mercury changing from a gas to a liquid. So we need to find mercury. Here's mercury. It's a gas at this temperature. It's a liquid it's a liquid here. It makes a change at 357. What is the name of the state chamber described above? That's called condensation. Let's see, would sulfur be a solid, liquid, or a gas in a pot of boiling water? Well, water boils at 100 degrees. So the question is, what state of matter is sulfur in when it's at 100 degrees? So let's go take a look. At 100 degrees, here's sulfur. 100 degrees would be here in the solid range. So our answer has to be solid. What is the lowest temperature that mercury can be a liquid? Well, let's go take a look. Here is mercury. Here's where it's a liquid. It can be liquid until it gets to the melting point. So the lowest temperature it can be liquid is -39. Okay. At what temperature do the atoms of salt begin to move past each other? Now, when atoms start moving past each other, that's when it goes from being a solid to a liquid. So what we're talking about doing here is melting. So we got to find is the melting point of salt. And the melting point of salt is 808. What is the name of state change described above? That's called melting. If I was in Antarctica and the temperature was -50, would ammonia be a solid, liquid, or gas? So let's go take a look at ammonia. Here's ammonia. It's -50, and -50 is in this region. -50 is colder than -33 and warmer than here. So in this case, ammonia would be a liquid. And what is state of matter is hydrogen in the sun? That is in a plasma state. Stars are in a plasma state, as is lightning, and some arc welding and things like that. Alright, on the back side of our paper, atoms begin to lock into place. That's called freezing. Becoming a solid. A direct change from solid to gas, that's sublimation. Atoms that were in contact begin to move away from each other. So no longer in contact, it's becoming a gas, that's called boiling. Atoms begin to change positions. So it wasn't able to change position, now they are. That means they're going from being a solid to a liquid, and that's called melting. The atoms begin to stick together when they touch, and that means in other words, they're not moving away from each other, so they're colliding and not bouncing off each other anymore, so they're starting to remain in contact. That's called condensation. What state of matter is characterized by molecules that are in contact and cannot move past each other? That's a solid state. State of matter characterized by molecules that are not in contact. Well, they're not in contact with each other. That's definitely a gas. State of matter characterized by molecules that are in contact and can move past each other. That's what a liquid is. Why do solids have a definite shape? It's because the atoms are locked in place. Another way of saying that is the molecules cannot change positions. They cannot slide past each other. Oh, we're almost done here. Ooh, look at that graph. All right, beautiful. All right, number 28. Look at the graph above. What is the melting point of the substance? Well, when you look at these graphs, here's what I want you to see. I want you to see that there are two plateaus, one here and one here. This is a heating curve because it's getting warmer. And there's three slope regions, this one, and this one. So the slope regions represent the three states of matter. Here it's a solid, here it's a liquid, and here it's a gas. Alright, so let's see. So melting means going from solid to a liquid, and that's happening at this temperature right here. So I come across, it looks to me like that's happening at about 300 degrees. Identify the substance of the graph by comparing its melting point to those shown on the state change on the other side. So in this case, it looks like it melted. Let's just check it. It melted around 300, and it boiled around 17 or 1800. So if I flip my paper over and look at it, that looks like it lines up pretty well with lead. And then let's see, how long did the melting process take place once it began? Well, melting started here at, looks like it started melting at about 20 minutes, and it finished melting at about 60. So the difference between this, so that means it was melting for maybe 10, 20, 30, looks like about 40 seconds. All right, and we're done with our homework. That wasn't so bad now, was it?